stretch in Chennai city from June 13 to June 14, 1 year during his PG, and repair and renovation and restoration of water bodies in Vellore district for 2 years from 2016 to 2018. Then he has done work on this Kudi Maramatu for 3 months, and he has worked in some packages in 2018. National Hydrology Project from August 2018 to May 2020. And he has been building artificial recharge wells in tanks in Agaramaru sub-basin from June 2020 till date. He is presently working with this Water Resources Department, Government of Tamilnadu. He is working at Vellore. Over to Kumaran. Thank you, sir. We welcome you for this program to give us an enlightenment into the subject water resources management in Tamil Nadu.
Thank you, Chairman, sir. Thanks for the brief introduction. So today I'll be presenting on water resources management in TN, with a specific emphasis on groundwater management. This is the water map that we all might have seen since our school days. Basically, water from the ocean evaporates and becomes a cloud, and ultimately it comes back to the ocean. So in between, what are the things that are happening, and maybe that I will explain a little bit with this drawing. Basically, whenever rain falls, we try to hold it in the reservoir, which you can see. Maybe if you can see my mouse, you can see it pretty clearly.
Screen advance agala.
Yeah. Yes. But in full screen la irukku.
இல்ல நீங்க உங்க next screen போகும்போது இங்க மாறணும்ல, அந்த first screen ஓட இருக்கு. Or when I share எடுத்து now it has come, you make it full screen also.
Full screen la தான் இருக்கு.
அப்படியா? சரி, screen advance ஆயிருக்கு இப்போ. Okay. Any other people who can respond to this, that is it in full screen mode for them?
No,
okay,
no, it is only PowerPoint mode. You have to come to slideshow mode.
Slideshow mode. Slideshow mode.
F5 key, function 5 key.
இல்ல அது கொடுத்துட்டேன் ஸ்லைட்ஷோல. எனக்கு வந்து full screen தான் காட்டுது.
அப்படிங்களா? Okay. Okay, you proceed, ma. Now it has come to this water map.
Okay.
It is showing
next slide தெரியுதுங்களா?
சேஞ்ச் பண்ணுங்க.
சேஞ்ச் பண்ணிட்டேன், பட் ஆனா தெரியல.
ஆமா, இங்க மாறல.
ஓகே.
இப்ப மாறி இருக்கு.
ஓகே, இதுல தெரியுது, பட்
it takes some time, I think.
ஓகே.
குமரன் சார்.
மேடம்.
சார் உங்க வீடியோ ஆஃப் பண்ணிருங்க சார். அப்ப வந்து உங்களுக்கு இன்னும் கொஞ்சம் பேண்ட்வித் நல்லா இருக்கும் சார்.
ஓகே, பேண்ட்வித் ப்ராப்ளம் ஆகுது.
இப்போ ஓகே சார்.
ஓகே.
full screen mode வர மாட்டேங்குது. Okay, let us see this.
Okay, basically whenever rain falls, we try to hold it in the reservoir, and by a system called either dam, barrage, or check dam, or whatever it is. From there the stream flows, and finally it reaches the ocean. Basically what is happening is, the idea is like the flow of the water from the reservoir to the ocean is taking place, and a lot of things are happening in between. For example, whatever these blue color items you are seeing, right? These are the surface water. We call it, if it is above the surface, we call it as surface water, and if it is beneath the surface, we either call it as groundwater or subsurface water. Basically, maybe in the next slide it will be a little bit clear, I think. I will go to the next slide and I will come back. To start with, we generally hear TMC in any news whenever the water resources or water. Just 1 second. Okay. I hope you can hear me now. Coming to the units,
You are audible.
Okay. Basically, a single cubic feet is equivalent of 28.32 liters, which we all know, and a cubic meter equals 1000 liters. But whenever the volume is high, we generally go for TMC or BCM. BCM is generally used in the energy sector. Sticking back to TMC, which is 1000 million cubic feet or 1 billion cubic feet. It's 10 power 9 cubic feet. Simple as that. And BCM is similarly billion cubic meters or 1 cubic kilometer, because 1 cubic kilometer equal to 10 power 9 cubic meters. Actually, this slide shows the distribution of Earth's water. Actually, this slide will make up the entire presentation. For example, first let us see the first column of water. I mean the first column. If you can see my mouse. Out of
we are able to see.
Yeah, out of the total water available in the world, the oceans are the saline water. It contributes about 96.5%, and this cannot be managed or used directly, so we can leave that out. And the saline part, saline groundwater or the saline surface water, which is in the lakes, these contribute together for about 1%. So adding these two, we get 97.5%, and the remaining 2.5 freshwater% contributes of the fresh water. And only this 2.5% of fresh water needs to be managed. So in the second column, considering the 2.5% of fresh water as 100%, around 68.6% is sitting as glaciers and ice caps. Remaining 30.1% is groundwater, and the remaining 1.3% is surface water. Now we can see the contrast between groundwater and the surface water percentage. For example, surface water is 1.3 and groundwater is 30.1, which is almost 20 times. Now, considering the surface water 1.3% as 100%, we get to the next column. Out of this 1.3%, ice and snow that is on the surface, that contributes about 73.1%. Lakes contributes about 20.1%, and the remaining atmospheric water, biological water, which is in the body of every living being, and rivers, swamps and marshlands, soil moisture, altogether comprise of the remaining as mentioned here. So the basic idea is, if we want to hit the right coin, the best way to manage is to manage the groundwater, because it is contributing about 30.1% of the total 2.5% fresh water. Whereas if you see the surface water and the available surface water, which are just rivers and lakes, for example, rivers contribute just 0.46% and lakes 20.1%. So adding these two, we get 20.5, rounding it off. So 20.5% of 1.3% of 2.5%. This is the surface water availability in the entire world. The scenario may not change much even for Tamilnadu. Now going back to the water map, we can see that we are 1, 2, 3, 4. These are the groundwater recharge zones. These two are extraction points, agricultural supply well and industrial supply well. Whereas the these four from the irrigated land or general inflow throughout the flow of the river or stream or anything. This contributes the groundwater. Going back to the water availability in India, this is only a rough picture. Average annual rainfall of India is about 1200 mm, with definitely the spatial unevenness is there. For example, Cherrapunji will contribute about 10,900 mm annual average, whereas in Rajasthan it will be only around 100 mm. But if you average area, you get 1200 mm for the whole of India. So multiplying with the area, we get total annual water available in India is around 4000 BCM, which is billion cubic meter. There are around 5000 dams in India, and they contribute only about 200 BCM. We can see the stark contrast. Out of the 400 BCM that we get as rainfall, we have only 200 BCM storage capacity through the dams. Now the next slide. So how we get water in Tamil Nadu? Basically, we have two monsoons, and the northeast monsoon is the predominant one with 450 mm rainfall, which contributes about 48%, and the southwest monsoon contributes about 305 mm, which is about 32%. Rest of the year and summer showers together contribute about 20% of the annual rainfall. Overall annual average for TN is 945 mm. So what does this 945 mm convey? We'll come back to that. Annual water requirement for the entire Tamil Nadu is only around 1260 TMC. We have around 118 dams, with one more dam we are building to be completed in the 2022. So capacity of all these 118 dams put together, we get only around 440 TMC, and capacity we have around 35,000 large tanks and some 4,000 smaller tanks. The capacity of all these 39,000 tanks put together comes around 390 TMC. So the total storage capacity of the entire Tamil Nadu on the surface, that is above the ground level, is only 830 TMC, which is the sum of 440 and 390, which means we fall short by 430 TMC. So in the previous slide, we saw that Tamil Nadu gets a rainfall of about 945 mm. So what does this convey? Just standing water column is 0.945 meter, multiplying with the area of Tamil Nadu, which is 130 square kilometers. Sorry, 130,000 square kilometers. We get around 4,340 TMC. So as rain, we are getting around 4,340 TMC, but our actual annual requirement itself is 1260 TMC. Yet we are falling short by 430 TMC. Next, the consumption split up. One interesting factor that we can see is either be it groundwater or surface water. Majority of the consumption goes to agriculture. Just to give a simple idea of how much water we are spending for agriculture, we need to get to know about these two terms. Delta. Delta is nothing but the depth of water required to raise a crop over a unit area. For example, if you are cultivating paddy for 1 acre, how much water is required for its entire growth, starting from the seeding to harvesting? The water column required for that entire process, we call it as delta, and duty is something like the area of land that can be irrigated with a unit volume of water supplied across the base period. Base period is the period from seeding to harvesting. For example, let us see. If we are having 1 acre of paddy, we are trying to harvest 1 acre of paddy. 1 acre equals 43,560 square feet. Delta is 120 centimeter, roughly 4 feet. So multiply these two, get volume of water that is required to cultivate paddy for 1 acre, which is approximately 50 lakh liters. I'm basically telling these because this gives an idea of where we should concentrate. For example, if we are concentrating on saving water from industrial or domestic use, we may not achieve much. But instead, if we are concentrating on using water efficiently for agriculture, maybe we will really achieve something. Okay. For all these agricultural requirements, there is a separate department, agri department, which is working on all these things. They are giving out a lot of methods of innovative irrigation like sprinkler, drip, etc., and change of crops. Instead of paddy, they are suggesting a lot of other crops, even crop rotation, etc., based on geography, topology, etc. Everything is coming under them. They are taking care of this. So I will move from this to the next thing. Why we should go for artificial recharge structures? Basically, artificial recharge structures aim at augmenting the natural replacement of groundwater. Basically, they are structures that augment the naturally happening process of replenishment of groundwater. Any choice or a method is governed by the local topography, geology, and general soil conditions, the quantity of water to be recharged, and the ultimate water use. In special circumstances, land value, water quality, etc., and the climate will come into picture. Advantages of going into artificial recharge structures. Basically, subsurface storage is free of cost. We can store as much as we want. And evaporation losses are negligible. Generally, evaporation losses for surface water storage is around 5% annually. So that loss can be cut off. Water quality improves by infiltration. Generally, soil acts as a filter media. So whenever infiltration is happening, water quality definitely improves. There are no social impacts. Social impacts in the sense, no need of relocating the population by grabbing land. Next one. These artificial recharge structures generally prevent soil erosion, flood, and also provide sufficient soil moisture even during the summer months. It provides a natural distribution system between recharge and discharge point. This is one of the major reasons why we go for artificial recharge structures. Also, it results in energy saving due to the reduction in suction and delivery head as a result of rise in water levels. There are various methods, direct, indirect, and combination methods. Let us not go deep into these things. But out of these different methods, what are the methods that might suit the geography or the topology of Tamilnadu? The artificial recharge structures that are relevant to Tamilnadu. In Tamilnadu, we go for artificial recharge wells or recharge shafts and check dams. These recharge shafts are the smaller version of the artificial recharge wells. I have given a drawing of the artificial recharge well. Maybe the next drawing will be much more clear. This is the plan, half plan at the top and half plan at foundation. Reinforcement plates, the side view. Maybe this cross section, if you can zoom out, it will be, these are the things that we are actually doing in Vellore. See, this is the ground level. There is a outer well of dia 12 meter and the inner well of dia 8 meter. The depth is decided based on the particular lithology. Lithology is nothing but the arrangement of soil layers. Maybe if the top soil is around 1 or 2 meters and below there are rocks, all these arrangements might change, but the typical drawing is somewhat similar to this. What we are trying to do is, these things are generally built in the tanks. Tanks means lakes. So we dig up to a depth of about 10 meters and from there we go for bore wells. The main aim is to punch the aquitard. In the water map, maybe I'll go back again. See, here we can see that there is an aquitard. It is nothing but an impermeable layer below which there will be unconfined aquifer and above which there is a confined aquifer. If we are recharging these aquifers, it will actually, these spans across kilometers together. So if you are providing water here, maybe you can drop here. That is the concept. So if we can punch to this and if we can recharge only the excess water, we generally don't recharge whatever water that is available, only the excess water that is available in a particular tank will be recharged. So that is the basic concept. So we go for bore wells inside the well, and these are used simply to punch through the aquitard and recharge the aquifer. The length and all varies from place to place. One such structure that we are building in Vellore. This project is not yet completed. Given some photos. Okay. This is in the almost completion stage near Pallikonda. The completed picture I could not provide. This is one thing. This is about the artificial recharge well. Besides this, what we can do is we can, if the basic concept is if we slow down the flow of water, it will automatically recharge the ground. So in order to slow down, we have to create a barrage. That barrage can be a check dam, a Nalla Bund, or any barrage of that kind. Simple and cost effective measure is to go for a Nalla Bund. This is nothing but arrangement of several pieces of random rubble tied up with some gabion structures. This will be arranged in this form and covered in a layer of gabion, that is a steel mesh, so that the entire mass cannot move, and it's very cheap. It comes around 8 to 10,000 rupees. That's all. These can be built across smaller or drains like this. This is one of the supply channel. This channel is presently dry, but it is feeding a tank. So if we can provide a lot of Nalla Bunds, maybe say in the range of 100 to 200 meters gap, it will run and it will recharge. Basically, if you see the Nalla Bund, the height is very, very small, around 30 to 50 centimeter. So only 30 to 50 centimeter water we are trying to stack behind this, and in the process it will recharge in the same channel itself. And we have some, if the width of the channel is high, we generally go for check dams. Basically beyond 5 meters, we go for check dams. They can be masonry check dams or concrete check dams. This can be extended even to rivers as dikes. Okay. We have reached the end. So I'll give a I'll come back again. Okay, with this we can talk. Since there is a lot of potential to tap groundwater rather than tapping surface water. For example, even though we have around 4,300 TMC of rain every year, we have storage capacity of only 860 TMC. This is basically because this is the quantity that we can actually store. Remaining has to go to the ocean. On the way, we can try to recharge the entire ground. This is the basic concept that I was trying to tell. Well, that's all. I think we have reached the end.
You have provided us with a lot of time for discussion now.
Yeah.
Actually, in this Kaliswaram project in this Telangana state, they pump the water from lower levels to upper levels and store it, and they use it for agriculture.
Yes.
Because they have almost all through the year their water flow is there in their rivers, so they don't want to go to sea. In fact, they want to utilize every drop of water for cultivation purpose. Similar situation is not available in Tamilnadu, since we also see dry Kaveri, sometimes flowing Kaveri for some months like that. So
Yes,
our source of water is mainly we are dependent on this rain.
Yes.
That is one point. But for this recharging and check dams, even in Ponnai River, the Andhra Pradesh people have put up a lot of check dams, and we are not even getting water through the Ponnai because of this heavy rains. It was flowing full. Otherwise,
actually, the height of the check dams define the flow downstream.
Okay.
Wherever we are suggesting check dams, that local people may be happy to say okay, but the people downstream, they generally opposed to this because water may not flow to the tail end. That is what is actually happening.
Yes, it's all
if there is a check or a guideline in deciding the height of the check dam, maybe everyone will get water. That is why we generally in Tamil Nadu PWD, wherever we go for a check dam, we suggest 0.3 to 0.5 meter only.
Okay.
That will align with the bed slope of the actual channel as well. So that we are doing.
So I have a suggestion. In the check dams, is it possible to provide some kind of gate or something like that, so that even though you can keep whatever height you want to have it, and if you have opening gate, you can open it so that it flows through that, right?
Actually, we have a scour vent, but other than that, we don't have any gate arrangements.
I mean, what I'm saying is, if you modify it, it may be better use.
Okay,
right?
okay. So that we can have altering heights.
Right.
Yes.
But how will you go and?
No. That will be opposed by a lot of people downstream.
No, people may open, may close it because we cannot have control because it is in a remote places, So basically, I have a doubt.
Yes, sir.
Now, the water flow, whether we are having some statistics in which area it is going more and flowing more and going to the sea, which area, for example, Polar River, we are not seeing any water flow entire for the, even in the peak period, only this year it is full. Otherwise, it's not flowing fully.
Yes.
But there are certain, maybe certain rivers where the water level always is high, but it goes into the sea. Whether any statistics has been taken, because of the two things. One is lakes we have occupied. Number two, the water flow line also we have altered by occupying this one. So naturally the water which was earlier collected in the hill station during rainy season is diverted or taking a different path for reaching the sea. Whether it is true, my statement, or it is in the original path only.
No. It is true actually. It is not in the original path.
Okay. Now, when it is not in the original path, like our forefathers did it, can we have some pond-like thing? In this the check dam normally it is pond only, but it is only limited to that area of or width of the flow.
Yes.
Can we identify areas where this flow can be diverted and taken to the pond, and afterwards it again flows into the sea? Like that, of course, this in a layman way I am asking.
No, sir. It's an excellent point. Maybe I can brief a little bit. We can store water only in places of depression. And depression, by depression, I mean that naturally formed depression, which is what you are meaning, that a lake or a pond or a tank. So, geographically, every depression will automatically fill up with water. And what happened is, even Velachery or T Nagar, it used to be a lake previously, but now it is not so. We have considerably reduced the area of storage.
Yeah, that's correct.
Yeah. So
No,
reclaiming
only
this
thing,
area is not possible.
now we cannot take back that area because
Yeah.
it is all occupied.
Occupied.
Now, can we identify some other area where the flow can be diverted, like in Andhra Pradesh, they pump it. Instead of pumping it, we can divert it to some place where there is no much of people living, and then take it to the, means the stream has to be manually rerouted. Instead
Rerouted.
of
Yes.
natural stream, we may have to reroute the stream so that the water what we are getting during this rainy season is trapped in a pond or in a well, as you are now telling. Maybe this is a new version of this one. So whether any scheme is being thought about
No, no.
in this
As of now,
direction?
no such scheme is in place. Basically, because the
Mhm.
geography should support it. Maybe we can pump, that is one thing. But naturally, if you have to make the flow happen, the geography should support it. But in my view, storing water on the surface is not the point that we should actually go for, because surface flow is just about 2%, whereas subsurface storage is about 30% of the actual available fresh water. So we should be concentrating more on the subsurface storage, and there are a lot of scopes for that.
No, what you are telling is the subsurface water quantity is more, no doubt about it. But once we start pumping it out, again it has to be replenished. That is,
That's why we have to let the water stay still,
yeah,
or
that
reduce the
can
flow
be,
velocity.
that can be done only through surface water. Am I correct?
Yes, definitely.
Okay. Why I'm asking this is, when I came to Paddy from BHL, my well was at water level was at 30 feet or 35 feet.
Okay.
Now it has gone to 70 feet.
Okay.
Obviously, whatever water we are using, it goes to the sewage water, and sewage water we are not pumping it out to river. Maybe it is getting drained in the subsurface only. Of course, evaporation is there. Now, the groundwater depletion is due to many people using the water. Instead of earlier, it was only for 1 acre of land. Now, many people are using it. So that means this is to be replenished.
Yes.
So groundwater replenishment, in my opinion, can be done only through the surface water.
Yes.
Now, surface water, we get it in two forms. One is used water, which is to be recycled and put it in the ground. The other one is the rainwater, which is collected or flowing through the river. Yeah, other rainwater, okay. Now, can we not make it mandatory for buildings to have their own rainwater harvesting well, so that the surface water will get a little bit recharged?
Yes, sir. That is already in place, I think, sir. In for example, in Vellore, or at least in my locality, it was made mandatory in, I think, 99 or 2000. By 2005, every household had a rainwater harvesting system. Not only privately owned land, but even government owned land with the buildings on it. They were made mandatory to have a rainwater harvesting facility. But
Now
comparing the total,
here my observation, this rainwater harvesting facility, the people are making and just showing, and our see, we are sharing as an engineer, not as this one. Whether it is built properly so that the rainwater will get harvested into the ground, that check is not being done. So instead, what I am suggesting is, if it is possible, anybody who is going to come with a plan, this rainwater harvesting well can be constructed by the corporation itself at a concessional rate.
Okay.
So that this quality and specifications, everything is met. Again, another my observation is, this whoever is inspecting that groundwater well, they have to make a report, and that should be filed along with the approval given for this building construction. Because a lot of malpractices, everything is being done. To correct it, whoever is signing it, he is responsible. If somebody goes and check up, if it is not in the proper depth or proper diameter, then he should be punished. Only when we bring that into force, I don't think, yes, all the concept is there with us, but practically we are not doing it. Why I am telling, I built the well after taking into consideration, but nobody came and checked up. That was my, of course, I did it as per the specification, being an engineer. But this may happen with so many people because our people are not having their social responsibility.
Yes.
So it is better that we make it a mandatory rule for this rainwater harvesting. This
Yes, sir.
this suggestion you can probably.
I will pass it on to the corporation.
Yeah, yeah. Thank you.
But your point is really good, sir. Maybe making it mandatory or having a check will ensure that.
Yeah, mandatory. Then construction by the corporation at a concessional rate, and even the corporation is going to construct. It is not corporation. It is again they are going to give a tender, and some contractor will do it. We should not allow the contractor to do any deviation
Any
or
division
lesser
should
work.
be arrested. Yeah.
That we have to ensure. That what we are doing at BHL is we are having a quality plan. And every stage, say for example, the diameter. Then a man who is inspecting it, he has to record and put it in the record file. Say for example, groundwater harvesting well, in my opinion, diameter one should certify, the depth one should certify, the filling one should certify. These three stages somebody should visit, and he has to make a report, and that should be filed in the corporation records. So if the man is doing any deviation or he is not at all visiting but still giving a certificate, he should be punished. Unless this punishment tool comes into picture, we will not be able to implement. This is my opinion.
Okay. Actually, I will share my idea, sir. I mean, like the total area of any place. I mean, the ratio of built-up area to the total area. The built-up area will be much less, right? The ratio will be much lesser. So what I think is maybe we can concentrate on the built-up area by implementing these rainwater harvesting structures at a smaller scale for every household.
Yeah, that's what my point.
But my idea is like, what happens to the area that is not actually built up? That contributes a major portion.
Okay, that your point is well taken. Okay. As long as they give a approval for a layout from an agricultural land, as engineers, we will not be able to suggest anything. See, that requires, if I tell the people will beat me, if it is not constructed for 5 years, then the land should be taken back. It's not possible.
It's not possible.
Okay. So, the unbuilt area, we cannot touch it. Only thing is, when we allow people to construct house, we should not allow in the this area where we can store the water. I mean water path. But that is all being done and has been done also. So what we can do, we have to only think of.
Sir, thank you for the suggestions. I think it's a very long discussion being done on the same subject. Actually, it is the conclusion is urbanization. See, in the particular area in those days, villages were having only 30-40 houses. Now in the particular area, we have multiplex complexes, and we want to live in a place where heavily crowded fashion. So definitely this sort of lacunas will come to address it. Government is also doing all possible measures. We understand. We also will help. Thank you.
Thank you.
I have a question on the slide where it showed different distributions, probably slide 2 or so.
Okay, I'll go back. Yes, sir.
Yeah. So in this slide, you mentioned the last column, like ice and snow, 73%. I'm kind of concerned about the validity of this one. In Tamil Nadu, we don't
Can you
get
make
any
it?
ice or
இன்னும் கொஞ்சம் பெருசு பண்ண முடியுமா குமரன்? அந்த பர்சன்டேஜ்ல கொஞ்சம் பெருசு பண்ணுங்களா?
So in Tamil Nadu, we don't get ice and snow.
That
right?
is definitely
Only
true.
Hilly places.
Yeah, I can actually tell. Consider ice and snow as lakes. You still get only 1.3%.
No, that particular percentage, is it valid for Tamil Nadu?
It is not valid. Maybe the heading, maybe you missed, I think, sir. Distribution of Earth's water. Distribution of water in the entire Earth, that is only pictured here.
Oh, okay. I thought you mentioned that it is valid for Tamil Nadu also. Okay.
The percentages may not change much for any portion of the world. So instead of ice, consider it as lakes for Tamil Nadu, but still you get only 1.3% of the fresh water.
Okay.
That's
okay. Good. Thank you. And another question is like the ocean has 96.5% of water.
Yes, sir.
Is there any projects that are going on like desalination of water and bringing it to land?
Actually, there are two projects in Chennai itself, I think, that is coming under Chennai Metro Water Department. So I don't have much idea, but there are plans. Sir.
Okay, thank you.
Sir, I can answer for that. Actually, at Meenjur, 100 ml plant is there. It's directly draws seawater from our Bay of Bengal, and it is being desalinated, and the produced water is again mixed with the water body available for catering to Chennai water's requirement. So similarly at Nemeli, another 400 ml plant is already is on and it is working. So similarly for catering to the drinking water requirement of the city where the population is more, the government of India or government of Tamil Nadu has put up these seawater desalination plants. It is there, sir. Even in nowadays in power plants also, we make use of the seawater for producing service water requirements and other demineralized water requirement also by using desalination technique. Thank you, sir.
Thank you.
Any other questions?
Hello. Hello.
Secretary, sir.
Sir.
You can now take over for proposing the vote of thanks for this session.
Okay, sir. I'll make the formal proposal.
After a very long gap, we have gathered here with the highest number of participants today. We are very happy to have Mr. Kumaran here, and I request our Honorary Secretary, Ranipet Local Center, to propose a vote of thanks.
Yes, sir. Thank you, sir. It gives me immense pleasure to propose the vote of thanks for this program on behalf of Ranipet Local Center. I thank Engineer Mr. Kumaran for presenting on this topic, water management in Tamil Nadu, and overview. Your presentation has provided us with insights on topics such as water map, water availability and requirements of India, Tamil Nadu, artificial recharge structures, etc. I thank our chairman for arranging this session amidst tight schedule. I thank Tamil Nadu State Center for enabling this online session through VC. I also take this opportunity to thank all the participants for their active involvement and interest shown. Once again, thanking you, Anand. Thank you.
Thank you.
Thank you. Bye.
Thank you, Chairman, sir.
Bye bye.
Thank you. Bye bye.
Thank you. Thank you all.
Thank you, Mr. Kumaran. Thank you, Mr. Manalan.
Thank you, sir.
Vivek, for the wonderful session.
Sir, நீங்க என்ன